Hello students, welcome to the session. I am Mr. M.H. Mota, Assistant Professor, Department of Civil Engineering. This session is on wastewater treatment. The outcome of this session. At the end of this session, you will be in a position to explain the basics of wastewater treatments used conventionally. So, wastewater treatment. When wastewater discharged into a river body, such as lake, river or sea, a number of processes occurs like physical, chemical or biological process. And these processes generally results in the degradation or the pollution of the water bodies in which the wastewater is discharged. The extent of pollution depends upon the type of pollutants present in the effluent. Effluent means the wastewater that has been discharged into the water body. Non-biodegradable pollutants like mercury are most deadly as they accumulate in aquatic organisms, which led to biomagnification. The large quantity of biodegradable waste can affect living organisms in water bodies in which wastes are discharged. It is necessary to treat such effluent or wastewater before discharging into the water body as such. Municipal wastewater treatment systems are designed to serve the needs of towns or cities. So, in such treatment plants or treatment units, conventionally, the systems involved are the collection of wastewater, then its preliminary treatment, primary treatment, followed by secondary treatment, and advanced or tertiary treatments. And after that, what followed is the disposal of residue which are there in the form of liquid waste, which is a treated wastewater, and the sludge, which might be semi-solid in nature and needs a careful disposal. The primary treatment. In primary treatment, suspended solids or floating material is removed. So, effluent passes through a screen which is used to remove the certain materials which are large in size like wood pieces, plastic, paper or floating debris. These have been removed by a process of screening. The effluent is passed afterwards through the chamber which is known as grit chamber. These are designed for the removal of inorganic settleable solids. So those have been removed in the grit chamber. After that, the fatty or oily substances can be removed by a flotation method. This can be achieved by using either a skimming tank or centrifugal separators. The water after that is passed in a settling tank, which is popularly known as a primary sedimentation tank, in which water remains for a long time in a quiescent state or in a without much disturbance, in which suspended solids can settle down. So all these primary treatments are generally treatments which are based on the mechanical means of removing or mechanical forces. The primary treatment, whatever we have discussed, are bar screens as shown in figure, which generally used to have a screen. These screens can be of three types, which can be either very fine or used to have a moderate or large openings, followed by a grit chamber, then a skimming tank, and at last the sedimentation tank. So these are the figures of such treatments. After that, the secondary treatment is used. Secondary treatment is even called as a biological treatment. The major reason behind this is that we generally take the aid or help of the bacteria or biological forces to treat the water. So it is the process in which microorganisms play a very important role for the treatment of effluent. The microorganisms like bacteria, fungi, decomposes the organic waste and convert it into a simpler form, which is far more acceptable for discharging that wastewater into an environment. The main function of a secondary treatment is to convert the remaining organic matter of sewage into stable form by oxidation and nitrification. So again, biological treatments can be classified into two heads. One is activated sludge process and second is trickling filters. These both are the things in which the aerobic bacteria are used, or aerobic microorganisms are used for the cleaning or the degradation of organic waste present in water. Or in other words, we can say that in these processes generally a very high amount of BOD has been removed. So activated sludge process. This is the most versatile biological oxidation process employed for the treatment of wastewater, which contains dissolved solids, colloids, coarse solids and organic matter. So sewage from sedimentation tank, primary sedimentation tank in particular, enters into the activated sludge process, which contains once again the two subunits. One is a secondary sedimentation tank, before which the aeration tank is placed. So sewage from the primary sedimentation tank initially enters into the aeration tank. Here 20 to 30% of active sludge is mixed. Sludge is the certain semi-solid settled material from the secondary sedimentation tank, and this mixture is aerated and mixed in the tank for about 4 to 8 hours. In these 4 to 8 hours, generally the very high amount of microorganisms which are active in nature. Active means something which is very fast in degrading or consuming the organic waste that is present in the wastewater, and are the major part which are present in the sludge which has been mixed in the wastewater to be treated in aeration tank. The mixture is aerated and mixed in the tank for about 4 to 8 hours. An efficient aeration for 3 to 6 hours is occupied for sludge, while for industrial waste the time is higher because it generally used to have a very high oxygen demand as compared to the municipal wastewater, where the water needs 6 to 24 hours of aeration. The microorganisms oxidize organic matter in the presence of abundant quantity of oxygen that is available in aeration tank. So in aeration tank generally we add a very high amount of air continuously with the mixture of wastewater and activated sludge. Then it is allowed to settle in a secondary sedimentation tank. Generally what happens is that when the organisms consume the biological waste in the wastewater, they generally tend to increase their settleability, and because of this the secondary sedimentation tank is provided, where the sedimentation or settling of this treated wastewater takes place. And in that treated wastewater, once again the sludge is formed in the form of something that has been settled down and which contains the high amount of or high concentration of microorganism in it. So this settled sewage has undergone aeration and has active microorganisms, so some portion of that is recirculated into the aeration tank once again, so that we are actually resulting in addition of the microorganisms which are active in nature, which has already undergone the process of aeration and are very fast in degrading the wastewater. The activated sludge is obtained by settling sewage in the presence of excess oxygen. So thus the activated sludge is that sludge which settled down after the sewage has been freely aerated and agitated for a certain time. The activated sludge is biologically active and contains a large number of aerobic bacteria and other microorganisms. When an activated sludge is mixed with effluent, the aerobic bacteria oxidize the organic matter present in it and promote coagulation and flocculation. So this figure describes the actual process of activated sludge, in which the two major components are aeration tanks and clarifier. Clarifier means the secondary sedimentation tank. So influent initially coming into aeration tank, where the aeration takes place and then the sedimentation takes place in the clarifier. From top the treated wastewater has been uh, carried out of this system, well, from bottom the sludge is obtained and part of that has been recirculated with the influent. Next is the trickling filter. It is another version or another type of the aerated secondary treatment. So after primary treatment, the effluent is passed through the beds of filter medium, which is making the body of trickling filter, and which consists a bed of stone in which microorganisms or bacteria are present. So these bacteria get nutrients or food from the wastewater that has been discharged in a trickling filter, and so they attack on carbohydrates, proteins, oils, fats, which is essential for the growth of such bacteria, and in process remove such objectionable matter which are present in the form of pollutants in wastewater and make water clean and more acceptable for discharging it into an environment or any further use as such. Then comes the tertiary treatments, which are even called as an advanced wastewater treatment. So the main function of such tertiary treatment is to decrease the load of nitrogen and phosphorus compound present in the effluent by the following process. So these processes can be a precipitation, nitrogen stripping, and chlorination. Either one or more than one process can be used, but such processes are very limited extent in Indian conditions, or rather we can say that very less plants are there which are actually using the tertiary treatments in the conventional wastewater treatment processes. Next process are the sludge dewatering and drying. So the sludge is an outcome of the sedimentation processes that are taken place in two steps. From the primary sedimentation tank, certain sludge has been obtained, and from secondary sedimentation tank, again certain sludge is obtained, and it is very essential to treat those. So that sludge treatment includes the different steps like thickening of sludge, where the water concentration has been reduced. This is essential for removing or rather reducing the overall volume of the sludge in initial phase, followed by a digestion in which pathogen inactivation and odor control is done. After that, the conditioning is done. So conditioning is improved dewatering, means water concentration is still reduced, and that can be achieved with the help of chemicals like alum and exposing the sludge to high temperature. Then once again the dewatering is done for the pathogen inactivation and odor control, and finally the incineration in few cases has been practiced for the overall reduction of volume and weight, and then that sludge is disposed along with the solid that has been disposed from a city. Generally in India we follow first two steps where thickening and digestion takes place, and whatever byproduct is there has got a very good nutrient concentration in it, as those things not have been exposed to tertiary treatments, and then we can use that as an soil conditioner for the agricultural activities. So that's it for this session. Let's meet in next session to know more about various secondary treatments in particular. Thank you for your patience learning, and don't forget to like, comment and subscribe. Thank you.